to negative t equals 0.01. Good. Same idea, same thing. I have no clue what this is. I apply natural log to both sides. I bring negative t in front. And I divide by -1. And I approximate. Okay. So let's continue with this calculation. What was it? Negative natural log of 0.01. So it's 4.61. And you go back and check if you would like to, and I would always recommend that. Now, let's look at 51 through 60. This time we are not asked, this is not an equation, we're only asked to find the domain. Okay, so let me start one and you choose the next. I know we have 5 minutes left. So f of x equals natural log of 4 minus x. So let's go back for a moment to the original base function. This is a different function because it doesn't have x, it has 4 minus x, so it's a different function, but it's still natural log. The domain of this function is 0 to infinity. How did I come up with this? From the graph. The domain of natural log, common log, any log, plain x is 0 to infinity. In other words, like with the square root, whatever I have in the square root, this quantity has to be greater than or equal to 0. Like with the rational function, this one cannot equal 0. Here, the rule is this, whatever it is, has to be strictly greater than 0. But this function is not applied to x. Is applied to 4 minus x. Therefore, 4 minus x has to be greater than 0. So I have to solve this inequality to find the domain of this function. Here, I solve this inequality to find the domain of this function. Here, for the square root, I have to solve this inequality greater than or equal to 0. For the rational function, this denominator cannot equal 0. So now I have to solve this to find the domain of this function. So 4 minus x has to be greater than 0, not equal to. I move 4 to the other side. And I have to remember that whenever I divide or multiply both sides of an inequality by a negative number, what has to happen?
Flip the sign.
Thank you. So then the domain of this function is negative infinity to 4. Let's look at one more, and I promise to stop. Thank you, George. Okay. So here we have two functions. Let's say 55. So two functions have to exist at the same time. So y equals natural log of x plus 3 plus natural log of 5 minus x. We'll stop after this one. Good. So, can anyone give us the condition for this one? And then the condition I have to write for this one. Not the solved ones, just the condition. What should I write for this one?
X plus 3 is greater than 0.
Excellent. And for this one?
5 minus x is greater than 0.
Excellent. I have to put these two together because they are two functions. So x greater than -3, and here negative x greater than -5, I divide by -1, x less than 5. Both. How do I determine the domain? This is the real line or the number line. I graph the first one first, greater than -3. So let's say -3 is here. This is the first one in red. And now I have in green, let's say this is 5. In green, I have this. This is in green. Less than 5, from -infinity to 5. In red, greater than -3. I need the territory that has both colors, the red and the green at the same time, and that is the domain of the entire function. Can anyone give us the domain of the entire function? Both colors at the same time.
-3 to 5.
Thank you. That's all there is to it. That's where both colors exist. If I choose this territory, only this one is correct, or exists, I should say. If I choose this territory, only this one exists. But if I choose this territory, both exist at the same time. Exist plus exist, I can determine. Exist plus non-existing, I have nothing. Non-existing plus existing, I can't add. They both have to exist at the same time, and they both exist only here. Otherwise, I would